Okay, students, again, let's proceed. Coming next is question number 17. It says, find the equation of a plane containing the points A, B, C. These 3 points are given. So let's now find the equation of the plane. So simple. Since the points lie on the plane, the vectors AB and AC lie on the plane too. So the points here A, B, C lie on the plane. So the vectors made by AB and AC can also lie on the plane. But how can we find the vector AB? Vector AB is obtained simply deducting components of B from A, students. So I mean components of A from B. So what we need to do is 2 minus 1 is 1, as you see, and minus 1 minus 0, I mean minus 1 minus 0 is minus 1. And 1 minus minus 1 comes to be 2, and come to this, AC is minus 1 minus 1, which actually is minus 2, 1 minus 0 is 1, and minus 2, minus minus 1 makes minus 1. So the located vectors, the position vectors are now known. So vector AB and the vector AC are now known. So what we need to do is we have to look for the normal vectors of the normal vector of these two vectors, because this is supposed to be normal not only to the vectors but also to the plane. Okay, so we can consider the output of this result as ABC because it's going to be normal to the plane. So let's calculate the cross product of AB and AC. So AB cross AC is going to be like this: 1 minus 1 2 crossed with minus 2 1 minus 1. So as usual, you have to label I minus JK here. So AB components are written 1 minus 1 2, as you see, and AC components are written minus 2 1 minus 1. So the I component can easily be obtained by deleting the first row and the first column, and this will be 1 minus 2 because this makes 1 and this makes 2, 1 minus 2 can come. And the J component is take the minus 1 in front and then delete the first row and second column, and you will get minus 1 and plus 4 because this makes minus 1 and this makes minus 4 plus 4J. And for the last one, delete the first row and the third column, you will obtain 1 times 1 1 minus 2K. So finally you will obtain this to be minus I minus 3J minus K. So here, students, the coefficient of I, which actually minus 1, can be taken as A, and B can also be minus 3, and C can be minus 1. So this vector can be a normal vector to the plane, because as long as the vectors lie on the plane, the cross product of the two vectors is not only normal to the vectors, but also it's perpendicular to or normal to the plane. So what comes next is the following one. The equation of the plane can now be determined in the following sense: x minus x naught. Your x naught here is number 1. You are free to take this one. And y minus y naught. Your y naught is 0 here. And z minus z naught. Your z naught is minus 1 here. So this must be dotted with the normal one. This is a normal vector, and this must make 0. Because this is the vector lying on the plane and this is a normal vector, so the dot product must make 0. So when you calculate that, you are going to have minus of x minus 1 minus 3y minus of z plus 1 equals 0, and the final output comes like this. Now, dear students, I want to tell you something here. Before you confirm that this is the equation of the plane, make sure that this equation, the plane equation, can satisfy what those ABC coordinates, those points coordinates, please, because these points lie on the plane, so necessarily these three points coordinates must satisfy what the given plane equation. Good. Now what comes next is question number 8. In question number 8, students, you are asked to find the equation of a plane containing the point 1 minus 1 2 and the vectors u and v. Basically, the idea is the same, so we need to carry out the cross product of u and v, and that is supposed to be normal to not only the vectors u and v, but also normal to the plane. And we do have here x naught 1, y naught minus 1, and z naught 2, so we can consider that point as CC, a point lying on the plane. So using these two, we can determine the equation of the plane. Let you follow me how I'm going to do that. So since the point 1 minus 1 2 and the vectors u and v lie on the plane, we can calculate the cross product of u and v and consider that as a normal one. So the cross product of u and v is going to be, as I tried to explain earlier, the norm of the magnitude of I minus jk with 1, 1 minus 2, minus 2, 3, 1, the determinant of this one basically. And this is 1 plus 6i minus 1 minus 4j plus 3 plus 2k, and this makes 7i plus 3j plus 5k. So students, this is going to be normal to the plane. So what we can do is the following one. So what comes next is this 7i plus 3j plus 5k is already obtained. So now we can proceed. The equation of the plane is going to be x minus 1 comma y plus 1 z minus 2. Basically this is obtained as x minus x naught, your x naught is 1, and y minus y naught, your y naught is minus 1, so minus minus makes plus, so y plus 1, z minus z naught, so z naught is 2, dot with the normal 1, 7, 3, 5. This must yield 0, so from this we can obtain this as student 7 into x minus 1 plus 3y plus 3 plus 5 into z minus 2 equals 0. And from this, the equation of the plane is obtained to be 7x plus 3y plus 5z minus 40 equals 0. So this is how you can obtain, okay, the equation of the plane. Now what comes next is question number 19, students. Here you are asked to find the equation of a plane parallel to the plane this and containing the point 1, minus 1, 2. So how are you going to find the equation of the plane parallel to the given plane? Basically what you need to do is, you see, the normal vector to the given plane must also be normal to the other or the intended plane. So if we are given, okay, that condition, so we can easily obtain the equation of the plane, because one point where the plane is going to pass through is also given. So the procedure goes like this. Since the two vectors are parallel, so the normal vector to one plane is going to be normal to the other, because the two are parallel, students. So basically the normal vector to the other plane is directly obtained just watching the coefficients of x, y, z. So the coefficients of x, y, z are 2, minus 3, and 1, right? They can easily be obtained from this one, x2, y minus 3, and the coefficient of z here is 1. So we can directly take that one as 2, minus 3, 1. Now students, you may consider this as A, B, C. And one point here lying on the plane is also given. So you are free to have here x naught 1 and y naught minus 1 and z naught to be 2. So the equation of the plane now can be determined by using this one. This is the equation, or the standard equation, how the standard equation of the plane is going to be obtained. So x minus x naught, y minus y naught, z minus z naught, dotted with ABC equals 0. So your A, B, C are these values, 2, minus 3, 1, normal components, and x naught, y naught, z naughts are, you see, coordinates of the point, where you see the points lying on the plane, 1, minus 1, 2. So try to substitute these values here in their corresponding place. So here in place of A have 2, in place of B take minus 3, and in place of C take 1. And here in place of x naught, y naught, and z naught, please take 1, minus 1, 2 respectively. So by substituting this, you see, you will come across with this kind of equation: x minus 1, y plus 1, z minus 2, dotted with 2, minus 3, 1, 0. Now what comes next is just to carry out dot product with the 2. So this x minus 1 will be multiplied by 2, plus y plus 1 is multiplied by minus 3, plus z minus 2 is multiplied by 1, and that has to be equated with 0. So you will get this expression. Then what you need to do is try to operate this and collect like terms together, and what you are going to obtain is this: 2x minus 2 minus 3y minus 3 plus z minus 2 equals 0. And then again, as I said, collect like terms together. You will obtain this to be 2x minus 3y plus z minus 7, in fact, yeah, because minus 2 minus 3 makes minus 5, and minus 2 minus 7, right, we are. So this is going to be the final output, okay, the equation of the plane. So how do you assure that the obtained answer is right or not? Try to watch the coefficients, students. If you observe the coefficients of the last output with the given one, you see they have the same coefficients. Look, the coefficients of x, y, z for the first plane is 2 minus 3, 1. Here we got also 2 minus 3, 1. This shows you that the two are parallel. Our d values are quite different. There it was minus 4, but now it's minus 7, so they are parallel in fact. And you need to check also whether you see the coordinates of the given points satisfying this or not. So when you substitute x1 there and y minus 1 and 2 in place of z, you'll obtain 7. And 7 minus 7 makes 0. So what we obtained is the right answer.